Okay, everyone. Today we are going to do this lab 2.3.2.6. Okay, configuring PEP and check. Okay, so I'm going to walk through with you all the steps. Okay, and we'll try to complete it together, and I'll explain as we go on. Right. So before we start, please analyze the topology first here. Okay, and then understand the addressing table, and lastly the objective. So we have three routers here, R1, R2, R3, which belongs to you. So the internal routing is done via EIGRP. Okay, so there is an external interface over here. Okay, so three objectives here. First, review routing configuration. Second is configuring PPP as the configuration method. Third one is configuring PPP authentication. Okay, so let's see step 1 first. Okay, so the background first. Okay. You will practice configuring PPP encapsulation on serial link. So remember, for PPP is only applicable on serial link. Okay. You will also configure PPP PAP authentication and PPP chat authentication. These are the two optional authentication for PPP encapsulation. Okay, without these two, PPP still can work. Okay, so let's review routing configuration. So all these three routers, okay, belongs to you, and it has already been configured with certain configuration. So part 1 is actually to understand what has been configured in your topology. Okay, so let's go through one by one. So let's look at R1 first. Okay, so in here it enables you to look at the CLI. Okay, so first I would like to check the show running config. Okay, so what I'm interested here to look at is the serial. Okay, so this is the serial from R1 to R3. Okay, right, so currently it is not PPP, it's under the default HDLC. Right, so we have an IGRP configured here. Okay, so passive towards this interface. Okay, that's it. So for further checking on the routing, so let's check the routing table. Show IP route. Okay, so IP route here, we have the 10 network here, 10.1, then 10.2 over here. Okay, 192.168.10, this is network. Okay, it's on network. 168.30.0, which is this one. Okay, and then you have one here, which is the default route. Okay, DEX. Okay, this is the default route. Okay, towards any to any network. Okay, so via here. Okay, right. So this is for R1. Let's look at R2. So R2 should have some similar configuration with R1. Okay, so this serial interface here, okay, S001, currently on HDLC. Okay, and there is an EIGRP. Okay, for this 1 and 2 network. Okay, so let's check the routing table. Show IP route. Okay, right. So the main reason I always stress to check the routing in order to know that where is your connection level now. So basically all three routers will have an identical routing table. Okay. Right, so here 10.0.0.1 here, okay, 1 and 2.10 is here, and then its own network 30.0, and then similar default route, okay, to go out to the rest. via here. Okay, so if your routing table is okay, you can see all this entry. By default, your layer 2 interface should be okay. If you want to check, show interface brief. Okay, right? So you can see here the status is up and up. This is layer 2, okay? So if your layer 2 is okay, your EIGRP can converge here. Okay, alright. Okay, so let's check the last router, route 3. Show running config first. Okay, so this to serial to R1 and R2. So you can see this under HDLC. How do I know HDLC? Because that's the default. So to ISP is also HDLC. Okay. Alright, so EIGRP here. Okay, you can see here is distribute static. Means that there is a static route configured in R3 to be shared with R1 and R2 via the distribute static. Okay, so this is the static or the default. I will call this a default. Why? Because of this any to any. Okay, so this is our door, your network door towards the outside. Okay, in order for this to be shared with R1 and R2, you need this command in EIGRP. Okay, if it's in OSPF, you will put the default information originally. It's the same. Okay, you don't configure default static here and here. Okay, you configure here your border gateway router, the last router towards the internet or outside, and then it will distribute to R1 and R2. Okay, right, so let's check the routing. Show IP route. Okay, right, so if you compare here in R1, okay, let's put R1 and R3 side by side. Okay, right, so you can see the internal remains the same except for the last one. Okay, because you configure the default route in R3. Okay, so the entry will be something like this. That particular information you share to R1. Okay, via the static distribution. Okay, so this is the information that you share to R1. Okay, so now looks like all our 3 routers are connected and together with the internal network. Okay, so let's check the instruction. Okay, so test connectivity between computer and web server. So it asks you to ping from PC and laptop to ping the web server IP. Okay, so be sure to ping from the PC and the laptop to the web server, not from R1 or R2. Okay, if you ping from R1 and R2, it is not an end-to-end. Okay, this is your end host. Okay, so let's open up the PC. Okay, desktop, the command prompt. Okay, what is the IP again? This. Okay. Wait for the response. Okay, so PC1 successfully pinged the web server. Okay, so let's start laptop. Okay, so also successful. Alright, So let's ping each other. Okay, to do further testing here. We look at so I'm the laptop. So let's ping the PC. What is the IP for the PC? 10.1. Okay, so alright, it should work. Okay, alright. Okay, so part 1 is complete. Okay, so part 1, the main reason for part 1 is to do a connectivity test. It is a benchmarking behavior of your network. Means that, okay, by default, if you don't do anything, okay, when you load this file, all the connectivity is working. So when we move to part 2, we will be doing the encapsulation method. Okay, if your PC could not reach the web, or your PC cannot reach the laptop, you know that you can always fall back to HDLC. Okay. Alright, so I'm going to stop for part 1 now. Okay, before we continue